Okay, we are good. Yes, welcome to our second meetup this year. I hope we can go on like that. Today we have Esa here to talk about ArgoCD and OpenShift installation. There is Tapani and Artur will tell us about Eura 2021, actually a project that I have been working in as well. And then last but not least, Jarno will have some talk about Falco. So just a few words. I don't want to repeat myself, or we have been going through those things many times. So we are, Tampere Meetup is part of Cloud Native Nordics. So we are a community in the Nordics that is all those cities, they belong to that community, and we interact and we share sometimes also speakers in those cities. And in Finland we have Tampere, Turku. There is also Anton here. He is from the Turku meetup. Thanks for the streaming today. And then there's Helsinki. Lukas Kellström is running that. He will also join today later a bit. And yes, please, if you have any comments or anything how we can improve these meetups, please reach out to us. We have a website and also Slack channels. You can reach out there to us. And also, if you want to talk, please visit that link or just contact us in Slack or through the meetup. If you want to speak, we are always happy to get some new speakers here. Yes, so these are all the channels you can reach us. And yeah, I guess that's it for my side. Well, one thanks to Netum today for hosting this event. Really nice. Thank you, Tapani, for organizing this. And yeah, I'll give now the sponsor talk to Dima.
Thank you. Should we make it full screen? Right. Okay, hopefully I didn't break it. I haven't used Windows for quite a while. Okay, well, let's start. So the company presentation. Yes, a little bit about myself. I'm kind of not very used to making the non-technical talks, especially in English. So I'm sorry, yes, if something goes wrong. But I just thought for starters, like to tell you a little bit about myself. So yes, I'm Dmitry Mosaev. Tai lyhyesti Dima. Oh, you see, I'm kind of switching to Finnish already. So it's already like it wasn't planned. So yes, my name is Dmitry Mosaev, and so at short it should be Dima. And I am originally from Turku, from Finland, and I'm working in Netum as a full stack developer and Scrum Master, and I'm coding since 2003, so professionally since 2006. Well, professional means that I'm working for a company. It doesn't mean that I'm professional, but I'm working for a company. Yes. And well, I don't know why did I put this, but my backend stack is TypeScript, Java, Kotlin, Python, C#, C++, and C. So it's like in a in descending order. So the newest are the first, and the oldest one, the last. Front-end stack, React, Angular, TypeScript, and I work for Netum since 2018. So for 4 years, like maybe a month short of 4 years. Yes, and then a little bit about the Netum, like what company is this? So how many of you guys heard about Netum before today? Quite a lot, great. Of course we have quite a lot of Netum representatives here, but still it's a very good number. I'm positively surprised. And yes, a little bit about Netum. So yes, we are a profitably growing IT services house with over 20 years of experience of demanding IT projects. And yes, as you can see, there are a lot of customers, like from both public and private sector. So really like huge spectrum of customers. In operation since 2000, listed in Nasdaq 2021. So we had this process of like giving shares, well, not actually giving, but selling shares for a very good price. And here I highlighted, two very kind of, in my opinion, very important numbers. So you can see that this one, like the personal work years on average. So basically, like we have a very long, tenures at Netum. So like people work for 10 plus years. This is, I really found this amazing when I was making this presentation. Like, I think in the IT industry it's much less. It's like 3-4 years maybe, but 10 plus it's very, very big. And currently we have like maybe a little bit more than that people, like 250. So it's like a very big number. And if you think about this, how long do they work for the company? It's like really huge, like really very impressive number. So yes, a little bit about services. So yes, as you can see from this picture, like Netum provides with a very large spectrum of services. And here, I kind of highlighted the most important ones. So I hope that we don't have Netum guys from another department. Okay, I'm just kidding. But if we start from this, like digital services, like the one that kind of I'm representing and a couple of other guys too. So yes, this is one of the traditional core services, like, well, basically the programming, we can say it like that, like coding, developing. The second one would be another very traditional service. It's like continuity services, like in Finnish it's jatkuvauspalvelut, and it's like includes cloud platform operating services. So this is the one that Artur and Tapani are working, and well, Oliver used to. And another one that I highlighted is this cybersecurity. So this is like, it's growing very big in recent years, so this is like a huge topic, this cybersecurity thing. At Netum it's also growing quite a lot. We need more and more specialists for this. Yes, a little bit about offices. So we have offices across Finland, like almost in every big city. In Tampere we have 2. Maybe some of you already know that we have 2. Like the other one is like across the street, so it's like very close. In Helsinki, this picture is from the Helsinki office. This is very new. I myself haven't been there yet, but well, sometime. It's like, if I remember right, it's in Kamppi. Then in Pori, in Jyväskylä and Turku, we also have offices. Of course, you can also work remotely. I kind of realized when I was making this particular slide, I realized how old-fashioned it is, and because everyone works from home nowadays, so I had to put this as well. This is also possible at Netum. I mean, this is like the remote contract. Yes, and of course, this is like maybe the kind of the main idea of this presentation, like that we are hiring, and you can find plenty of like open positions. You can find them, for example, well, there are a lot of places. I just came up with 2 obvious ones, like the company website, and in LinkedIn. You can also find, actually, well, that's like, I applied when I came to Netum, I applied via LinkedIn, but it's, well, doesn't relate to that, but it's a very kind of simple way to do it. Yes, and of course you can ask like Netum guys directly for more info. We're always glad to help and to give some advice or like tell you a little bit more about how the stuff works here and stuff like that. So there are quite a plenty of us here today. Yes, so yeah, I would like to thank you, and if you have any questions or something, you just feel free to ask now or later. Like, yes, but yes, I warmly welcome you to this kind of event. Thank you.
Thank you. I guess we have to, well, what I forgot with me actually is Toni and also Jussi. They are also with me running this meetup here in Tampere. And yeah, let's start with the first presentation. I guess it's Esa.
Well, one thing you could mention is if people are dialing into the stream, they can also ask questions.
Yes, yeah. There is somebody on the chat, Anton. Yeah. So please ask questions if you have. If you want the microphone, you can take that. it should be enough. Well, maybe it's better you put it to. Okay.
Yeah, okay, I'm going there. Voisiko se sen sinne?
Now here.
Well, it doesn't like mirroring for some reason. I guess I'll just have to follow the slides from the big screen. So, ArgoCD and OpenShift is sort of story about one internal project of ours. Short introduction to myself. I'm a system specialist at Knowit. Been working there for about 5 hours. 5 years, I mean. Yeah. I was the tech lead for an internal Kubernetes project. We started using OpenShift, sort of dog fooding, because we sell support services for Kubernetes and so on. So we decided to move some of our internal services also to Kubernetes. I've been using Kubernetes in different forms for about 5 years, starting with OpenShift 3.0 or 3 point something, I mean, sort of something in the deep end with hundreds of moving components and hundreds of breaking components and trying to find my way through it. Then going to like smaller and simpler setups, some K3s, clusters at edge and so on. Now getting back to OpenShift in the 4.x. Also, well, most of my experience is in my home lab, often abusing Kubernetes for things like most people might not do with it, like just using the control plane, extending it for something, thinking, do I even need the kubelet? Do I need to care what the pod is? But turns out it's actually a useful way to schedule the control plane components, so I did use a kubelet. Also thinking about some CNI plugins and what interesting things I could do with the networking and combining with like NCFVs and some custom flows and so on. ArgoCD is a GitOps CD tool. Maybe most of you at least have heard of it. It's also packaged as a Red Hat OpenShift GitOps, which goes well with OpenShift the version 4, because in OpenShift basically everything is managed as a cluster resource, so you don't have Ansible playbooks that are configuring your nodes. Everything is custom resources inside the Kubernetes API. So if you've got a GitOps solution that manages your Kubernetes resources, you can have easily the entire cluster config in the same Git repos. ArgoCD is one of, maybe at least not so long ago, it was one of the 2 major GitOps packages Flux was the other one. In this project at Knowit, we were going to evaluate both, but then we heard that Red Hat announced that they are supporting ArgoCD as Red Hat OpenShift GitOps. So it made sense to go with the platform-supported version, and we did not end up evaluating Flux, but in other cases it's probably worth checking out. And I think most of you also know what GitOps is. It's been a big buzzword and over everywhere, but if somebody doesn't know, it's basically a pipeline that reads a Git repository and deploys resources to your clusters. Has all sorts of useful things, like you get a change history for free, you check git log, you see who changed, what changed, when changed. You can do peer-based workflows with reviews, approvals, so on. And you have if you use it properly, you have the full state in a Git repository, and you can just delete your cluster and redeploy. You don't have to think about that one guy who used kubectl edit some resource to fix something, and then you are missing that fix and you have no idea how to actually make it work. Sort of in this our project, we decided that everything is managed by ArgoCD. So we create a new OpenShift cluster. We have the script which basically condenses to install ArgoCD. And then we point it at the Git repo, which contains all the cluster configuration and application configuration. ArgoCD has this concept of application, which is basically a group of resources that are managed as, well, one group. We have a top level per cluster application which deploys more applications, one for the infra components and one for the user-facing workloads. So we end up something like this, where every box is a ArgoCD application which contains one or more resources. We have the infra side and the sort of user application side. What those applications contain, well, they point to a Git repo or a directory in a Git repo. You can have static files. You just create a Kubernetes YAML file, put it in the Git repo, push it to the branch, and ArgoCD will apply it. You can also use different templating systems. You can use Kustomize, JSONet, Helm, and so on. A lot of our files right now are just static, simple files with no templating. But there's a plan when we deploy more clusters and we decide something can be reused, then it might be converted to a template instead of just copying it. But we didn't do that sort of prematurely to spend hours on that. We use a bit of JSONet. We have some resources that we want to deploy to multiple namespaces. So we just have a variable that is an array of namespaces and some for loops that generate the different resources. And we use Helm mostly for external applications. We have some tools we want to install, and since Helm is pretty common way of packaging Kubernetes applications and tools, so that's the one that's easiest to use. Here is a screenshot from ArgoCD, one of our applications that serves ICS calendar files that are built from our duty roster for our duty officers for our 27 operations. You have the application on the left, and it deploys a bunch of resources like a deployment config, secrets, config maps, so on. And ArgoCD will also track, you can see there's the deployment config, which is basically OpenShift version of a deployment with some additions. It will track the replication controllers that are built from that DC, and it will also track the pods that are deployed from the RCs. So they're not directly managed by ArgoCD, but you can see the status of the application. But yeah, so far it's like everything seems simple. You put some files into a Git repo, it gets deployed to your cluster, everything is good. Well, not everything is as simple as that. We did run into some challenges. First of them was secrets. We don't just want to put plain text secrets in a Git repo. In some other environments, we might use, for example, Ansible Vault, which decrypts the secrets client side and then applies them to the cluster. But here it has to be, we have to send the encrypted version to ArgoCD and then let either ArgoCD do the decryption or let ArgoCD deploy an encrypted resource and let something else handle the decryption. But it must be done inside the cluster. There are these two projects. In the beginning, we weren't really using Helm in this environment, so we didn't run into Helm secrets. We ended up selecting this sealed secrets project. Basically, it adds a new CRD, custom resource definition. You get this sealed secret resource. On your own machine, you can, for example, create a secret, just standard Kubernetes secret file, and you encrypt it with the cluster public key. You create the resource in the cluster, for example, through ArgoCD, and there is a controller which sees that there's a new sealed resource, and it checks the metadata for some security reasons that it matches the correct namespace and name, and it will decrypt it inside the cluster. There are some downsides. For example, if you have an application that requires a config file that has a lot of parameters and you can't easily separate them to a secret, use, for example, environment variables or a second config file, you have to encrypt the whole thing. And if you want to change some memory parameters, you don't want to touch the passwords. They are fine, but you need to get the plain text config from somewhere. For example, pull it from the cluster, edit the parameters, re-encrypt it, push the encrypted file to the Git repo and deploy that. So it's a lot of manual work, and also it only supports output as a secret, not any other resource type. For the first problem, we solved it by creating our own simple template engine in the cluster. We have the config map that has like non-secret parts of the config. It has some simple variable substitutions, put the password here, and then we use sealed secrets to deploy a secret that has just the secret variables. Then we have this controller that runs inside the cluster that takes these two inputs and creates a new secret that has the whole config file together with all those memory parameters and the database password. It was built using a Python library called cof, which is really cool. You have this small snippet of code here. Basically, if you add one more line, put import cof, and then run this on your cluster, you have a working Kubernetes controller. This function will get called every time a config map changes inside the cluster. Of course, it doesn't do much, it just logs a line that says, okay, this changed. But you can, for example, create new resources based on that or change it. So, shout out to that. In our own implementation, it uses annotations. For example, when this is, well, ArgoCD has full cluster admin. That means if you got right access to the Git repo, you have basically cluster admin. You could create new roles, new accounts, or about anything. Something we decided that it's fine with us because we have a small team, and basically everybody who works on the cluster, they have admin anyway. So it's not an issue for us. It would be possible in ArgoCD to isolate some projects, only let them deploy to specific namespaces, only let deploy specific resources. And also a model I've seen, it's possible to run ArgoCD with a limited service account. So even if there is a bug in ArgoCD, it can't. Even if you can overcome these namespace limits, then ArgoCD just simply doesn't have the permissions to write anywhere else. So if you had different developer teams and you wanted to limit them to just a subset of your cluster, then you would probably be looking into these. Something we have done to sort of encourage the use of GitHubs and discourage the use of any manual edits. Even our admins have limited direct permissions to the cluster by default, so you can't go OC edit or kubectl edit anything. You can look at the cluster state, you can do things like kill pods if they're stuck, you can exec into pods to debug things, you can check logs, but you can't really create or modify resources. There is a workaround we allow using sort of sudo using this as system admin. Like in one of my previous commands, I wanted to list secrets, so I just added some permissions, so it's not really like prevented, but there's an extra step, so you sort of have to think like, do I really need this? Do I want to do this? We'll also let people create namespaces that, or OpenShift projects, they can create their own stuff in them. But we have a mutating webhook that if you create a new project, it prefixes it with your name. So if you want to create like a global project, then use ArgoCD. If you want to test something, then go ahead and create a project, and it will have your name on it, and everybody knows who it is and what it is. So that's the end of my presentation. I was planning on recording some sort of demo, but I finished these slides like half an hour before arriving here, so that has to wait for another time.
Have you tried using any plugins with ArgoCD? It has plugin support. We haven't, at least. We also run it, but we haven't tried any. Have you guys?
I don't do like, does application sets count as a plugin?
I think it's like a separate, I haven't really looked into it.
Yeah, it's a bit of like an extension, but I don't know where the, not really. But yeah, you can ask questions if you have any.
How about the, thanks. So how about the branching design? So when in GitOps you need the repository and branch that has the certain configs.
Yeah.
But there are various options. So what is your current, you have a, for example, branch per environment, or and what alternatives have you considered?
Yeah. At the moment we basically have just a one cluster, one environment, and it tracks the master branch in the Git repo. So if you want to push into production, then you do a pull request or somehow get your commits to master, and then it gets deployed.
Have you looked into other secret solutions? Like we use still secrets, but then we move to Vault just because of the issues that you mentioned, that they are really hard to, like if you want to do a small change in a big config map or something. Have you evaluated any other solution except still secrets?
We did look into some, but I don't remember like the exact. This is like over a year ago, I think, when we were like doing the early stages. But we also wanted to kind of keep it simple, and for example, HashiCorp Vault isn't like the simplest thing.
No.
Yeah, I've used it in some cases, but sealed secrets seemed like simple enough, and also quite similar to what we used, for example, our like Linux config management with Puppet. We used Hiera YAML, which is a really similar public key encryption scheme.
Thank you, Netum. I guess then, well, we have a short break, and next one is Tapani and Artur.
Koppi on kyllä mikä se hallittavuutta, jos sä vaatat tikkuun. Tavallaan sinne pienen skriptiin, mutta se on kopin mukaan, millä sä ylläpidät sitä ja se koppi kirjastuu. Voitaanko image-screenit sen, että se vaan?
Voisi se olla.
Se millä se buildataan se koppi?
Tällä hetkellä se on OC Start Build ja sen jälkeen asioita tapahtuu. Että
Niin, se on sitä kautta. Niin, se on nopeasti tuo toinen sillä
Build configin kautta ja tälleen.
Niin, se on hyvä kontesti, että voit heittää tuommoista. Sitten kun se tavallaan ruuhkaan koko ajan tekee, niin täytyy ruveta miettimään sitä buildaamista. Tosi joskushan mä oon nähnyt semmoisia ratkaisuja, että sä ottaisit kopin imagen ja sitten sä ollaan konfiguraatia laittaa koodin.
Juu.
Mistä sä voit ajaa sitä suoraan buildaamaan.
Pythonilla se onnistuu aika helposti.
Niin, ja vaikka koppiin se todennäköisesti toimisi, niin joututaan menemään.
Post ArgoCD. ArgoCD only sees the encrypted version.
For us, it's very important that disk is not existing in the cluster. So in principle, the only way is that the application would not read the secret. It would read from Vault, for example, would read it straight there and inject it into the application. So skipping completely the secrets in Kubernetes.
Okay.
But this is, I mean, with Vault we will have it, but with seal secrets we will not get it.
Yes.
But this is just what we have to live with temporarily. Yes, that's what I thought. So,
Yep.
But I will look into it. Sounds interesting.
Things get like a lot more difficult if you don't, in quotes, trust what's inside the cluster and so on.
Yes. Well, there are environments where that is fine, and then there are environments that are more secure where that is not fine. So that's our problem. So, but for some of our stuff, that makes sense to do it like that, definitely.
Yep.
And I think it's enough to at some point you trust people.
Yeah. Like in its basic form, that's like a thing we like. That simplicity has some of like limitations, as I said, but
There are always solutions.
aivan.
Ja kiitos muuten. Tosi hyvä esitys. Hyvin jäsennelty selkeästi. So more real-life stories. And this is about running Eura 2021 system on production on the top of Kubernetes platform. But before going any further, let's do a quick intro here. My name is Tapani Höök. I'm a member of Eura 2021 Cloud Platform team.
And my name is Artur Malinin. I am also a member of that same platform team.
And we are not the whole team. We are Kimmo here, who is taking care of the monitoring stuff, and then we have Juho.
Juho went to check out the food, so.
Yeah. That's a good thing. Let's check the contents of the presentation next. So, couple of words about the system itself. Then we check out the tech stack we have. Then we go to lessons we have learned. First, checking the infra as a code things, couple of those. Then Artur, you are going with
resource management in Kubernetes, security stuff, and some cases to share that we picked from different situations.
So next, the system itself. It is there and it is straight from Netum's web page, I think. What is this system? It's a web application basically, and it is used to manage the projects in a sense that those projects get funds from the European Union. The Euro, EU, it stands for the European Union. The system has a 7-year period, means that we are distributing the money, not us, but the government and the European Union during the 7-year period, so it's a long time. It channels billions of euros to different companies and organizations, and that of course means that this thing has very high meaning for society here in Finland. It has to be online and it has to respond when needed. And as it states there, it's of course a cooperation with the ministry. We cannot do things like that as an IT service house. And we went to production last November. And we have been building this one for 2.5 years now.
Yeah, something like that.
And I almost forget about the team. Oliver, special thanks go to Oliver. He has been very important member of the team in the past before you went to the OpenText. And then Kari Marttila from Metosin. He's not here, but anyway. Let's check out the platform or the tech stack first.
Yeah, so here you can see our tech stack with logos. So I think that the main thing is that we are running on AWS using Elastic Kubernetes Service. Some of the programs you see here, we are going to go through them in this presentation briefly, and some of them are not here because we don't want to mention them.
Sorry, we have very strict NDA and we cannot show demos, so sorry about that. But we can talk about the Pulmi. So that is the tool that is selected for the project as a code solution. It's a bit less known option than Terraform, so let's do a brief intro to that solution next. As I said, it is an infra as a code tool like Terraform in a sense that you can define and deploy your cloud infra with that one. Also, of course, the kube resources. So you might ask why we need another solution here, because we already had Terraform, the well-known thing. What is the problem we are solving here? And actually under the hood, the Pulmi is using the Terraform provider for the AWS. They also have now native provider. It's based on the AWS Cloud Control API. But it's not so mature yet, but we are using that one too. But the thing here is that with the Pulumi you can use your common programming language for defining your infra. That means that you can use all the loops, conditional logic. We use Python, so that's why we have modules, classes and packages there. But the other option, very much used, is the TypeScript. Of course, we have testing framework. The Python, we use the unit test. And what I like here is that this kind of tool, when you don't have like different domain-specific language for the infra defining, it really breaks the silos between the ops and the dev, because now we have the same kind of language, same tool sets, at least for the some part. And some other points there. This one can encrypt the secrets in the state file. Also, it means that it has a state file like a Terraform. We can do transformations for the kube resources, for the YAML manifests, for the Helm charts we are deploying. If we need to deploy the like third-party Helm chart and we need to do some kind of manipulation on the fly, we can do that. And it's also a cloud native in the sense that it has a cluster operator for GitOps. So, a couple of more words about the Pulumi. It organizes the project inside, or organizes the code inside the project. You write it using the Python or TypeScript. Then within a project you have your stacks, and most often those stacks map to environments like production and dev staging there. And nothing new there if you compare to like CloudFormation. Then we have those YAML files. Those are for the config, so that's a bit new. Maybe we can take a next slide now. And now we have a like story about not caring about the infra as a code practices. Maybe because we get fooled by the new tool. As we probably all know, with the kube you are using a YAML manifest and lots of those. You may use a Helm or just a plain manifest, but anyway. And you define your app and third-party applications you need for the cluster with those manifests. And in sense you are using the code, of course, already. But we already also know that with the YAML comes the repetitions. So even with the like most basic kube configs, we probably have some or a lot of repetitions. Or what you say?
Yeah.
You agree with that one. So the Pulumi supports native kube objects and Helm charts, like with defining those using the common language with the developers. You can use packages, modules to eliminate the copy-paste things and maybe share your best practices if you happen to have those. So we did all that, plus all the AWS cloud resources. So next one is the problem or the challenge. What happened? As you can see, that resource count did grow, like almost exponential growth in there. But we have a nice organized code there. We had our parameters. We used those to like take on and off different options for the infra. We had the feature toggles, stuff like that. We had nice modules. Then we were like closing the lifetime, and it was like a couple of weeks before that should happen. The customer did inform us that we should like migrate all infra to different AWS account. And this was basically because of some integrations. This is public sector project. The public sector had some integration like mounted directly to the AWS accounts located in the island region. So we had to like start the migration to new AWS account for the production stuff. That was already ready, of course. But we have too many resources there. We couldn't manage to do that. It took a week or two.
Yeah, maybe like between 7 and 9 days.
To deploy the infra. It wasn't a nice thing. We had many circular dependencies inside the modules. We didn't know those were hidden from us. I mean, we built those, but still hidden from us. And it was difficult to maintain. We were already like getting technical debt because of the like difficulties updating the stack.
And stack was getting also slow.
Yes, absolutely. Updating the stack was slow. So what did we do? What we do now? Let's take a new slide, maybe. Well, of course, we had to break the monolith stack. And how to do that? This is another story, and it's about that one. So first is the repo thing. And what we did is that we chose the monorepo approach, like for the new infra projects and the ones we want to split from the monolith stack. Not because we are building the whole infra together, but we had like some shared resources, components there, and it was pretty much easier to do it like this one. Then we did adopt some new tools. Like for the package management, we take a Poetry, and it makes also easy to like take care of the virtual environments we need for the Python, and especially with the GitHub Actions we were now using. And the other thing, the unit tests. We started to write unit tests during the stack development. Not until now. This is the first time we did that. But anyway, better sooner than later, or later than ever. But why? Because if the writing the unit test is difficult, then we know right away that probably we are writing another monolith stack. And that was the thing that helped me a lot during the development work and breaking the stacks. And some other things there. We need some stack dependencies for that. We had this old monolith stack and the new stacks. For that, we used the Pulumi stack references. There are other options for that, like using some kind of parameter database, but the Pulumi stack references was the easy one because we are actually defining most of the kube infra using the Pulumi. We also use AWS CDK, but that's another story. So the current situation, maybe we'll take a look of the GitHub repo for the new microstacks thing. We are currently deploying 3 stacks using the GitHub Actions, and one is for some reason in gray. But we are implementing more and more stacks using the GitHub Actions later. So we have some shared components now in this new monorepo. Those are located in that components folder, and those are actually the Pulumi component resources. So it's a Pulumi it's a higher level construct. And then we have some shared libraries. The actual infra is inside the infrastructure module or packages there. We are using lots of lambdas in our project, so now we have to split those from the monolith stack to the new serverless stack. Then we have a new application stack. This one is for managing third-party applications or services we are using for the cluster.
Yeah, they're mainly like Helm installations. We install Linkert and Calico and stuff like that.
Yeah, the Pulumi now has new implementation that is it's using like native Helm provider, so that is nice one. Then we have a config. We are not using that one in production yet. But the services, the Euro 21, it's basically microservice kind of system. So that's why we decided to go with the microstacks kind of infra approach with the infra as a code for the project. We are now creating new projects there, new Pulumi projects. We are creating a new infra stacks for the different Euro 21 microservice groups. For example, we have a bank integration microservice group, and for that thing we are defining config maps, and inside the config maps we have some AWS resources like SQS queues. We use a DynamoDB tables. We provision those tables and store the data we need inside the config maps. Then we need AWS EFS for the storage. We need some persistent storage for the bank integration files. And we need, of course, the kube persistent volumes for the EFS. So that kind of stuff is inside the new microstack. But that was about that. And Artur, please continue with your things.
One question.
Yes.
How do you deploy from the Git repo? Then do you use some kind of GitOps, or how is it like reconciling to the target cluster?
This moment we are using GitHub Actions. They have solutions in their marketplace. It's not GitOps. It's just
you deploy it when you do a change.
Yep.
Okay, so I can continue from here. Can we?
Oh, sorry.
You can leave it on the table as well.
Oh, okay. Yeah, I think it might be better. So, yeah, let's step out of Pulumi world a little bit and also touch other subject. So, let's talk about Kubernetes resource management. This is this is topic that is pretty basic, but we think that it's important to discuss. So we are mainly discussing here about CPU and RAM limitations for containers running in Kubernetes, and we picked like 3 main points why we think it's important, and the last point is we are basically telling how we did it and how we set it up. So our first main point is to reach better stability and reliability. So by defining CPU and RAM requests and limits, in our experience, it boosted our application and cluster reliability a lot better. So for example, at the beginning of the project, we had application and it had memory leak, and because we didn't have any kind of limitation on the RAM side, that application was crashing some nodes from our cluster, so it wasn't a good thing. And then later on, when we enabled horizontal pod autoscaler and cluster autoscaler, we also learned that both of those techniques are using they are based heavily on the resource requests. And that because we set the requests and limits at the beginning a correct way with a proper approach, it was easy for us to enable these technologies later on. So we didn't have to spend that much time doing it, on setting it up. Also, I think it's good to point out here that well, we are using cluster autoscaler and HPA, so it also might save some money in your infra if that's something that is important. So maybe point there. Now your workload. So how we did it in our environment and what challenges we faced. We are mainly running Clojure and TypeScript applications, and both of these applications need different of requests and limits for them to operate correctly. Clojure is, for my understanding, it's Java-based application, so it's running in the background Java virtual machine, and it has its own difficulties, let's say that way. But working tightly with developer teams and using Fairture deployments, Fairture namespace, we had it work, and we also didn't slow down that much developers, or at least we think that way. Developers may think differently. But yeah, so basically the key points how to get it work was to work with own environment, trial and error, run maybe some kind of load to it and test that it's worked correctly. Yes, so this is about resource management. Then let's go to the security. And let's firstly discuss with bot security policies or BSPs. So we enabled this in our environment, and well, I don't know how much you know about BSPs, but basically you can define that how the container is running with which kind of user ID, group ID, is the file system write protected and stuff like that. And in our project, of course, we did it on the later on part, so the application was partly already running. And by enabling this kind of policies, we had again use our own Fairture environment where we tested it in our own way. And when we proved that it was working correctly, we then merged it to the actual dev environment. And maybe good point here was that it's not all in the bot security policies. So you define the stuff there, but you need also deep dive to the container images and maybe base images itself. So if you are defining like user ID or group ID that container is not having, you need to deep dive to the base images to fix it. Or if you are defining a file system that is read only, you might have some situations. We had with Nginx, it was, if I remember correctly, it was related to logging or something, but the fix wasn't the base images itself. So maybe point from there. So then about network policies. So EKS, it doesn't have a network policy engine. So if you enable any kind of network policies, they will not work. They are in the cluster, but they don't do anything. So we decided to go with Calico. Calico was chosen mainly because AWS has a great documentation about it, and AWS is basically telling that, yeah, it's working. So that's why we chose it. And some stories about Calico. So why we actually needed network policies. We wanted namespace isolation. We are running multiple environments in single cluster, so they're basically regular to have. And especially when the bank integration came in, we decided that this is a thing that we must enable. And basically with the Calico was same thing like with bot security policies. The application was already at least at some level working, and we had to firewall everything up, so between the namespaces and between the microservices. So it was a nightmare at the beginning in the way that we had to deploy our own feature branch and test stuff there before we even think about to merge it to the development, so that we don't slow developers and cause any kind of problems with that. The next one is container image scanning inside cluster. I think this is a good point. When developers are writing some kind of code and they are publishing images, we are using Elastic Container Registry, and it has a scan-in feature on the push. But what about the images and containers that you are running in the cluster that you have installed with Helm, like Linkerd, Calico, any external secret stuff like that? You don't have any kind of contact point with those containers and the vulnerabilities that these containers might have. Here we are using Starboard, so we have, I think it's weekly scans or stuff like that. So we are scanning the cluster containers and checking out what kind of vulnerabilities we have. Of course, this is something that, because they are third-party applications, we can't patch them, but this is something that keep us informed about the possible threats and also keep us motivated to update those applications. Yeah, and then the last one is EIM roles for service accounts. This is something that we use for our own microservices and applications, and also for some third-party applications. And basically we can define with this link that specific Kubernetes microservice can use only specific AWS resource. For example, we have external secret plugin that is fetching secrets from the AWS secrets manager, and with this kind of connection we can limit that this specific microservice can only access AWS secrets manager, and only that. And this is also used in bank integration. Yeah.
Yes.
Yeah, this was the points in security, and then there is some random cases that we want to share. I don't know what was good topic to hear, so cases to share. Let's go with that. Some of these are like some kind of success stories, or we think that in our environment they are in good situation. Some are things that we learned, and some of these things are stuff that we need to address in the future. The first thing is environments for different use cases. For our opinion, this is something that is working really nice in our environment. In our dev cluster, at the best, we are running like between 10 and 15 versions of the software, and it's really easy for developers or us to create new feature environments and test stuff there. And this is actually the way that we tested the Calico network policies and pod security policies. We just launched our own environment and played there. Then Linkerd and timeouts. So this is something that when Linkerd was enabled and we were happily running stuff into production, we actually noticed that there was 502 error codes between API Gateway and Linkerd. It wasn't that much. I think it was between 0.1 or 0.2% of all the requests. It might be much for some load, but it was, well, we noticed it. It was there, and actually client also noticed it. It was generating some tickets to our side. Of course, when the tickets arrived, we didn't know it, that it was based on this Linkerd timeout thing. So the thing is that Linkerd proxy that is injected to each pod has its own timeouts set to that proxy. And also we have the timeouts in the application itself. And because those timeouts didn't match, it was causing the 502 errors to appear and was actually visible to our client. And this was fixed by our side, so we patched not we, but the dev team patched the software itself to increase the timeout, and it was fixed by that. And Linked has, by the way, yeah, Linked has really good troubleshoot page about this 502 error and others. So if you are facing something like that, check it out. The third is network topology. So this is something that we think that is you should spend some time when you are creating your infra and your cluster. We are actually facing this problem at the dev environment, so we have too small subnet and it's limiting how many nodes we can have on that cluster. So this is something that we need to fix in the future. Of course, we learn our lesson, and in production we have, well, we shouldn't have the problem in the production. It's quite large in the production, but yeah.
Yeah, we have actually some integrations from the government side, and those ones make this a bit harder to fix.
Yes.
But it's doable.
Yeah.
You mean network routing between Kubernetes and...
It relates to the subnets and VPCs.
Yes. Then we have cron jobs here. So we are using cron jobs, I think, like probably everybody is using. But the thing here is that, like I said before, we have between 10 or 15 environments, and all of the environments share the same cron jobs setup. So it basically means that we can have 10 cron jobs launching at the same time. And if you have like heavy cron jobs, that might cause some problem if you don't have cluster scaling, or you're running in low capacity of your nodes. So this is something that we need to address in the future. I think this is something that we can probably fix with Pulumi by doing some loop or changing the timing via Pulumi. But it's something that we need to work out. Of course, we right now we don't. This is something that isn't affecting us directly, so our clusters can handle that load, so it's not a big problem, but just a good thing to know. And the last point is infra cluster. We have one. We have been using it in the past, but because of different kind of hurries and tasks and stuff like that, it's outdated. So it's good to have a playground that is only for infra. If you do anything there, you don't have to worry about developers sending you Slack messages and stuff like that. So we think that it's really good to have one, and we should update our own to the current situation.
And of course, you can see here the problem with that. We have a monolith stack. We cannot just spin out a new cluster this moment as easily as we wanted that to happen, but in the future.
Yes. Yeah, this is all for us. Do you have questions? Yep.
Yeah, you mentioned CPU and memory limits and so forth. Have you had issues with CPU throttling?
Some, but I think our main issues was at the beginning with RAM memory. So because of the Clojure application, it's doing some Java virtual machine magic in the background. We had to define pretty high CPU and RAM limits, because the spike is happening at the beginning when there's, I don't know what it's running into behind, but there's a spike, and after that it's just flats out. So this is something probably that we need to, in the future, to address and find a better solution, because we just have, I think that we have 3 gigabytes limit on memory there, and it's actually using probably like maybe between 300 and 500 megabytes.
Well, yes, we didn't have enough burst capacity for the virtual machine Java to spin out, and it was because of the we don't have enough virtual machines or nodes inside that cluster. So that of course caused some slow ups.
Yeah.
It's handled now.
Or I think Yeah.
Yeah, just go on.
No.
So I was thinking with secrets. So do you handle all your secrets through the secrets manager in AWS you mentioned, or do you have them stored somewhere else? Like how do you put them manually as secrets to Kubernetes?
Yeah, the AWS Secrets Manager, it's a kind of like singular source of truth for us, Stormen, and we are using this plugin you mentioned.
Yes, we are using external secrets to fetch the secrets from Secrets Manager, but we are also, like Tapani told, we store some secrets in the Pulumi config file itself. They are crypted with COMS keys, so they are not like in clear text in the GitHub repo. But basically we have like more infra kind of secrets are in the Pulumi stack, and more secrets that applications are using, they are in the Secrets Manager.
Yes, you can like use the AWS KMS to like encrypt the secrets and store those to Pulumi YAML file.
Yeah, and actually related to secrets, the external secrets plugin, or what is it, external secret manager, it's outdated, so they are not anymore, how you say it, it's deprecated, and they are recommending to use guess. So I think it's Kubernetes external secrets. It's more like kube way to do things, so it has operator that is managing stuff like that. So it's something that we probably need to change and update in the near future.
Yeah, you'll really see how fast the cube is.
Yeah. You barely have time to make the presentation before.
Yes, and there is
it's
actually
not there anymore.
Yes.
And actually one point that I forget to mention when talking about bot security policies, they are deprecated. So from Kubernetes 1.21 they are deprecated and removed in the 1.25. And yeah, I read that there is solution for it, but we need to, of course, implement it and test it and stuff like that.
But it's going to be a lot easier than bot security policies.
Okay. Let's hope so.
It is.
Okay.
PSP is failing by existence.
Okay, is there any more questions?
Yeah, how about Pulumi? Are you using fully open source Pulumi, or?
Yes.
And it's enough?
Yes, at this moment.
Yes, so
we don't have actually an option to use the managed service because the client does not allow that.
Yes, so our backend is in S3 buckets, and it's in because of the client, the buckets itself are in the EU region, so we can't use the managed Pulumi service. And
Thank you.
Thank you.
Now we have food.
Yes, food, yes, very much.
Ja, mä voin tulla.
Okay, I guess we're ready. So I'm gonna talk about runtime threat detection with Falco. I had some discussions here, and some people know it intimately, and some people haven't even heard about it. So this is more for the latter people. This is sort of first introduction to Falco. I'm not big on introducing myself, but I've been doing development for 20 plus years, and for the last year I've been doing cyber security at Fraktal, which is a small startup focused on cyber security for developers. So the question is, what the heck is Falco? And of course you can go to the web page of Falco and you can see a string of words that have a lot of buzzwords, of course. Those buzzwords are the ones that you people enjoy, but they are still buzzwords. It also has a section about why Falco, and it has things like strengthen container security, reduce risk via immediate alerts and so on, but these are also a little bit too low level. So why? The question of why should we use something like what Falco and what it does. So we start with the diagram of your application or service that you're running, and you run it on some servers. The service usually has some sort of API or something that connects to the internet, so that your users can use it, or you have APIs to other systems and so on, but there's the internet. And if it's connected to the internet, then there's the possibility that some malicious actor, some attacker wants to abuse your service. It's not only your service, but of course they want to target the CI/CD system or the servers that you're running on, and other things like phishing for credential access and so on. And for this, we build some protections in front of them, so to speak. So you have things like firewalls and other measures to restrict the access to these services. And the question is then, how watertight are these defenses? Of course, we want them to be absolutely watertight, but as it happens, it depends, because these measures, it depends on the sort of the intention and motivation of the attacker. So if we have a scale of the level of sophistication and determination of the attackers, you might have something like automated scripts running. If you put a web server in the internet, you will start seeing some attempts to abuse your PHP installation. And the other extreme, you have something like state level actors, so someone who has basically unlimited budget. And the sad reality is that even companies like Google, which have enormous defense, security defense budget, get hacked. In 2010, there was this Aurora incident that Google even said that they were hacked, and there were other companies also that were hacked in this breach, and we know a lot of these breaches. This quote was from a blog post by a security researcher, and he was asking this question, that why wasn't your system hacked? And his answer is that either the people who could hack your system haven't been bothered to do that yet, or the other option is that you have been compromised, but you just don't know it yet. And the same blog post also had this quote from the Brian Snow, who was some sort of director in the NSA, and he said that the reason that your systems are not breached is due to the sufferance of your opponents, meaning that they just don't care about your system. And the reason why this is the reality is that we have these zero-day vulnerabilities, which mean vulnerabilities that have been published but don't have mitigations. You have things you need to patch on your infrastructure. You have things like phishing and these novel supply chain attacks, like there was this dependency confusion attack lately. And well, the answer to the why Falco question is this second part, this that you have been compromised and you just don't know it. And if you search for the this area in the internet, you can find these articles that say that there are many cyber attacks, breaches that go undetected for weeks and months. And this is the problem that the Falco is trying to solve. So instead of looking from the outside and building those defenses on the outside, we start with the assumption that the attacker is inside your service, inside your servers, and we want to detect their presence there. Obviously, we don't want to make a system that once someone has a foothold in it, that it's automatically game over. We want to have some sort of building blocks, or inside the system we want to have defenses also. For example, we can run things inside containers. They provide some security, not much, but at least some. And you have in Kubernetes, you have things like these network policies. You can restrict access to other pods and so on. But the thing is with the attacker is that if they get a foothold, they typically want to do other things inside the wherever they have landed. For example, gaining access to another container or whatever the unit of execution is inside the system. And one particular example of these things that we cannot protect from the outside is this basic concept of a reverse shell, which might be injected somewhere inside the supply chain, and then when the reverse shell starts, it makes the connection from inside to outside, so whatever firewall you have there doesn't prevent that from happening. If you Google the Microsoft Kubernetes threat matrix, it looks like this. Don't be confused by the colors, it was just a version, but you can see that there's this classification of techniques that an attacker wants to do. Of course, you need some sort of initial access, but after that you need different things inside the system. You need to escalate your privileges or gain persistence so that you can maintain your foothold. You want to discover new things inside the cluster and so on. So this is where the Falco steps in, because in order to achieve the things that the attacker wants to achieve, they need to do something on the actual servers, and we make the Falco watch those servers. And in the highest level it looks like this. It's just that the Falco engine consumes system calls or the events system call events, and then it has an engine, and you give it some rules, and it generates alerts. It also has the possibility to use Kubernetes events from the audit logs, and nowadays it has also some sort of pluggable interface to use other sources, event sources. In a little bit more detail, this is from the homepage, there's some more elements of that actual implementation, but for this presentation this is not very important. But this is what it looks like. And the tagline or the idea with the Falco is that since it monitors system calls in the actual servers, the idea is that you have to do system calls in order to do something, and when you do it, it is what it is. If you read a file, it's a read file system call. And like I said, for the attacker to achieve anything, you need to do something inside the system. So simple examples, you read or write a file, you open a network connection, you spawn a process or whatever. So with these we can see one of the built-in rules inside that ships with Falco, which is a rule that monitors writes below a known binary directory. So this is more not like a typical cloud-native technique, but in Linux systems, the attacker might want to plant some binaries inside the binary directories.
That is actually an attack attempt if you're detecting after the bot starts an attempt to write to a binary directory. It's an attack attempt.
Yeah. But yeah, the point I was trying to make is that if we look just at the first line of this condition, which is the definition of when the event occurs, there's these names like bindir, openWrite, and fdir, and they can be macros defined elsewhere, and we'll look at that. But one macro defines what are the files that you want to monitor. The event direction is just when it happens in the system, and then we have the openWrite macro, which looks like this, and it's just a condition that says that if the system call is one of these, open AT, open AT2, and it has this flag is openWrite true. So then this event is triggered, or that part of the condition is true. It has some other things, but these are the ones that we're interested in. So when you do something like this, it doesn't have to be in a container, you can do it in a regular Linux machine, then it generates this output that a file below a known binary directory was opened for writing, and it has a long list of things about the event. It also has identification for if it runs in a container and so on. A more cloud-native or Kubernetes-related detection example is this one, which is detecting attempts to contact the Kubernetes API server from inside a container. So typically when you run containers and they don't have any special needs to contact the API server, which they don't, we can assume that something strange is happening if this is triggered. So just the network connection to the API server from inside the container is triggering this rule. And even the example of the reverse cell, there's also a rule about that. Of course, the actual rule is not, it says that it's a potential reverse cell, but if you actually do a reverse cell yourself, you can see this event triggering. So the one problem with all of the systems that generate events and alerts is that they will generate false positives, meaning that some legitimate activity is detected. So something that you do or your application does, and it triggers an alert. And as you can see from the previous example, there was this. The last line was this, that it is not some user-known contact Kubernetes API server activities. So we can assume that false positives happen. And it is true. And this is why it is true. There's a set of things that your application does and the operations that you do, and there's things that an attacker would do if they had a foothold and they have some intersection that some things look like an attack that you do and vice versa. But we're especially interested with this idea in mind that we want to detect the attackers, especially the things that the attacker must do, something like scanning the network. Then we know that our application never does this, because we know our application and we know how we operate the system. This means that you do probably need to fine-tune the rules a little bit, perhaps. It comes with a set of built-in rules, but you can fine-tune the rules. This was, as an example, you can make a condition about the container image repository. So if your application or part of your some microservice does something that looks like an attacker, then you can just say that, okay, this is fine. It can do these things. The good news is that you can identify what looks legitimate. And this is in contrast with if you work in some huge organization that has a security operations center and they get the events and they try to interpret it if it's something that shouldn't happen. But if you work in a sort of this new DevOps thing, you know your application, you operate it, you know that if something happens, it's fine, and you know when it is not fine. And even better news, if you do stuff in this cloud-native manner, it should make it even easier to deploy something like Falco and work with it. Just as a simple example, you could run a package manager inside a container. Maybe you are debugging something in the production and you need a netcat tool or something like this, but we know this is not the way you should do it. If you need tools inside containers, you do it during the build process. And even if you do need them in production in some emergency, you can just, you know that these events were generated by your own actions and so on. And well, running a package manager is not perhaps the thing that an attacker will do, but they might want to do it if they need more tools inside the container or whatever. And yeah, the closer to the cloud native way you do, the less false positives you will have, because the things that the built-in set contains are things that you shouldn't do anyhow. So in this sense, you could use the Falco just to improve your cloud nativeness. I don't know if it's a word, probably not, hopefully not. But yeah, so not just monitoring the activity, but if you see something that your application does that the Falco considers suspicious, then you could change your application to be more cloud native in this sense. And of course, you can improve your security posture, because you can see things that shouldn't happen inside your system. Okay, so Falco is not the only tool you can use for runtime threat detection. Just a few points why you should use Falco. Well, the homepage had some other reasons for using it, but the first thing is that it is open source. It's free to use however you want. You can block, nowadays you can block an event stream inside it, but you can block the output also. You have different ways of directing the alerts and so on. Other thing that I like about it is that it is a single purpose tool. It doesn't try to solve things like incident response. It doesn't stop containers. It only detects the things that are happening inside your cluster. It is, I think, pretty easy to understand, because the basic concept is so simple, and once you have this motivation behind it, and it does have this support for cloud native things. It understands containers, it understands some of the things about Kubernetes and so on. And the built-in detections are pretty solid as they are, so you don't have to build them from scratch. You can just deploy it as it is and see what events are generated. So it also has this possibility of using Kubernetes audit events. This diagram had the audit events mentioned, which you can feed to the engine. It's a little bit more complicated in that when you configure the API server to collect the audit events, and then you need to, well, one possibility is to post them to the Falco's embedded web server that then feeds it into the rule engine. But the nice thing about this is that it looks similar to the other rules. The difference is that we are talking about Kubernetes events here, so it's not about system calls, opening and reading. We are discussing about or considering Kubernetes events. So, as an example, you have things like you can make a macro that I guess it has it built-in macro, like consider the condition is about what verbs were used in this audit event and what was the target resource and so on. And then you can create the rules that this example is about creating disallowed pods. So you can say that the container image should be your private registry or whatever. But yeah, that's the presentation, the high-level overview of Falco runtime threat detection. So, questions or comments?
Well, what do you use as a backend? Like, where do you store the events? Do you just ship them to
Yeah, well, I've used that. There's you can use like external systems if you have something like what was the Atlassian? Anyone remember that? I don't know what you can feed to whatever system you have. But Elasticsearch is a typical.
Alert manager also.
Oh, okay.
Yeah. I think that if you go to look at the helm chart, you can see, I think it's under Falco sidekick. You can see from the helm chart what the integrations are.
So do you need to package it to the container image itself, or is it some side container? Or
Yeah, so I think the current recommendation is just to install it on the worker nodes and like not as a part of the pods or deployments or it used to be a daemon set. I guess you can install it that way also. I think it's fine also, but the recommended way is to install it on the servers and so on. Yeah.
Makes sense.
Yeah, and there's a couple of different options there too. You can install it as a kernel module or use this ePPF interface that the kernel nowadays has. So that's
anyway, nice tool.
Yeah.
Any experience how much you get false positives with the out-of-the-box rule set?
It depends on your application, I guess. But yeah, the first time I used it was we had it in EKS and it was installed by someone else, and we had these events and we didn't understand what they were, and there were quite a lot. And of course the problem is that if the detection is something that detects something that happens all the time, then the events get triggered all the time because it doesn't have any concept of stopping it at some point.
I heard some kind of similar tool which focus to you have those two circles in there. But from the network point of view, that when you follow the network traffic in the long term, you can draw the picture, and when something happens outside of that picture, it's probably hacker.
Yeah.
So it's the AI-based stuff what I mentioned. Is there some kind of AI-based stuff which can learn then how your software usually works and then start to figure out?
Yeah.
Is it outside of my software or not?
Yeah. Falco itself doesn't have that, but the company that is related to Falco, the SysDig company, they have their own products that have these. But I guess it's a closed source and paid product, but they do have, and of course you can build on top of Falco something that correlates the event and so on. But
when you say the SysDig, I know that.
Yeah, that's the one. But they were the ones that developed this originally, but they released it on open source and now it lives as its own project.
Yeah, no, just to comment to that, it's so hard kind of with AI or machine learning stuff as well, because then you can just, if the hacker is smart enough to understand that, it just like starts gradually doing all the things.
Yeah, and AI is something that is always being touted as the magical solution to everything, but maybe someday. Yeah.
Of course, it's not the magic of that.
Yeah.
Anyway, it can help you.
Yes, and someday it will replace our jobs, I guess. Not yet.
I want to see that day. Anyway, it won't.
Somebody has to make the AI.
Yeah. But yeah, thanks.
Yeah, thank you.
Thank you, Jarno.
So,
yeah, I'm not sure when the next one will be, but probably beginning of September, something like that. I believe everybody's on holidays now for the next.
what?